Alright, let me get your attention, please. Students will be able to use graphs and charts to evaluate limits and discover asymptotes. We will also start out with a process called derivative today, and we use limits. Limits are really the foundation of calculus, and we'll start this semester. We'll start this semester with limits, but halfway through the semester we'll do limits again. And I start out by saying, well, if you had the square root of, you don't have to write this down, 6 plus 4 minus 3 times 7, right? You would do square root of 6 plus 4 minus 21. You'd write square root of 6 minus 17, right? Yeah. No, you can do this. Square root of 10 minus 21. Excuse me, I got to do order of operations, right? Square root of negative 11, and then I end up with a negative value, but you get it. In that, you would write square root every time. Not one of you in here on the next step would write just 6 plus 4 minus 21, because you've been conditioned to write the square root every time, because it would look silly without it, right? So when we do limits, you got to write the limit statement every time, or you just won't get full credit. And I don't want that. I want you to write the limits down until you actually do the limit. All right, so let's look at our first problem. An object dropped from rest from the top of a tall building falls y equals 100 minus t squared feet in the first t seconds. Find the average speed during the first 6 seconds. Let's take a look at the first 6 seconds graphically. When we plug 0 in, we get 100. So that's the height we're at, 100. Then after 6 seconds, 100 minus 36. So at 6 seconds, 100 minus 30, 64? 64. And this is a parabola, and I know what parabola looks like, or what a parabola looks like. Looks like that. So if you want to find the average rate of change, or the average speed, or the average velocity, how'd you travel in your car? You go miles per hour, right? The distance over time. Miles per hour, feet per second. We got to find the distance it traveled divided by how much time it took. But you don't even have to think about it that much. We have the point 0, 100, and we have the point 6, 64. The average rate of change between these two things, if you find the difference in the distance over the distance or over the time, it really ends up being the slope of the secant line. The slope of the secant line is how fast you traveled. It's the slope. So we say that the average rate of change is equal to y2 minus y1 over x2 minus x1. It's slope of the secant line. It's equal to negative 36 over 6. So negative 6 feet per second is the velocity. 6 feet per second is the speed. Velocity has direction, speed does not have direction. But now we have a problem with the next one. Find the speed of the object at t equals 4 seconds and confirm your answer algebraically. It doesn't say from the first 6 seconds, which is really from 0 to 6 seconds, so that we can have 2 points. It only gives 1 point. Right at 4. So we have this point. We have 4, and we have f of 4. And we know that 100 minus 16 would be 84. So we know what that f of 4 would be. But that's only 1 point. We can't find the slope with 1 point. We need 2 points. So what we do is we say, well, let's manufacture this second x, and we'll call it 4 plus h. I know I wrote that really small. It says 4 plus h. So the point on the graph would be 4 plus h, comma, f of 4 plus h. Now we want those 2 points. That we could do the secant line between those 2 points, or we can move that point a little closer and do the secant line of those 2 points. But what we really want is the slope of the tangent line. We want the slope at 1 point. But we're going to do that using 2 points, one real one and one that we manufactured. So we want the limit, we want to find the limit as h approaches nothing, as the difference between 4 and 4 plus h become nothing. Now, how close would you have to be before you call it nothing? Maybe h is 0.000000001, and you're like, well, that's good enough. Or 0.0000000, infinite amount of zeros, 1. That's what we can do with calculus. We can get it infinitely close. And so our accuracy to the slope of the tangent line becomes infinitely accurate. So we have limit as h approaches 0 of really f of 4 plus h, y2 minus y1 over, let me write this off to the side, x2, which is 4 plus h minus x1, those will always cancel, so we just say over h. But we mean 4 plus h minus 4, or 7 plus h minus 7, or 10 plus h minus 10. Those will always cancel out, so we just say it's over h. That goes to the limit as h approaches 0. Now we got, the calculus is over. Now we got a lot of algebra to do. We're going to plug in 4 plus h, 100 minus 4 plus h squared minus 100 minus 16 all over h. We can't plug 0 in for h yet because h is in the denominator and we can't have 0 in the denominator. Let's keep working this out. Limit as h approaches 0 of 100 minus 16 plus 8h plus h squared minus 84 all over h. Limit as h approaches 0 of 84 plus 8h plus h squared minus 84 all over h. Now there's a good checkpoint in this problem to see if you're on the right track. Anything that does not have an h needs to cancel out, because I got to be able to cancel out the h in the denominator. That's a good news. That's a good sign that those cancel out. This goes to the limit as h approaches 0. Now I can factor an h out of the top. 8 plus h over h. That's good news. If that didn't happen, we would be stuck. Those cancel out. I got to write limit one more time. Limit as h approaches 0 of 8 plus, yeah.
For the third line,
negative.
Yeah.
Negative. Yeah. I lost the negatives. Thank you. So this becomes negative and negative. It better be negative because this is a falling object, by the way. Now I can plug 0 in for h. I don't need the limit statements. So negative 8 feet per second. And the question usually is, well, when do I need these limit statements and when do I don't? When you have 2 points, you don't need the limit statements at all. I have 2 points there. I can find the slope, no problem. It didn't say 2 points, but if it says the first 6, your first point's 0. When I don't have 2 points, when it just says t equals 4, at t equals 7, that's a problem. Now we need limits. I need to manufacture that second point, make sure they become 1 point. Let's practice it. An object dropped from rest from the top of a building falls y equals 50 minus 3t minus t squared feet in the first t seconds. Find the average speed during the first 4 seconds. So this is 2 points from 0 to 4. So average rate of change or average speed is equal to f of 4 minus f of 0 over 4 minus 0. Distance over time. 50 minus 12 minus 16. That's plugging 4 in there. Minus plug 0 in there. It just becomes 50. Over 4. These cancel out. Negative 28 over 4. Negative 7 feet per second. So that's really the velocity, the average velocity. No limits. I don't need them. I have 2 points. Limit's not necessary. This one, limit's necessary. We have the limit as h approaches 0 of f of 4 plus h minus f of 4 over just h. 4 plus h minus 4 is always going to be h in the denominator. Now we have some algebra to do. Limit as h approaches 0, plug 4 plus h in. That's a pain. We can get it done though. 50 minus 3 times 4 plus h minus 4 plus h squared. There's plugging in 4 plus h. Now plug in 4 minus 50 minus 12 minus 16. What's 50 minus 12? 38. What's 38 minus 16? 22? 22? All over h. All right, I have some algebra to do now. Limit as h approaches 0 of 50 minus 12 minus 3h minus 16 plus 8h plus h squared minus 22 all over h. Limit as h approaches 0 of 50 minus 12 minus 16, that's 22, minus 22, it's looking good. Looking good. Negative 3h minus 8h is negative 11h minus h squared all over h. Awesome. Everything that without an h canceled. That's good. Limit as h approaches 0 of negative 11 minus h. Limit as h approaches 0. Oh, no. I'm doing the limit. I'm doing the limit now. I finally don't need to write that because now we're going to plug 0 in for h. Negative 11 feet per second. Any questions? When you have 2 points, you don't need limits. It's not necessary. The only reason we're using limits is because we only have 1 point. And this 4 plus h is creating a new point and then dragging that point to the other one. I thought we'd review piecewise and then look at what is your homework going to look like other than what we just did. Consider the following function defined by its graph. Limit as x approaches negative 1 from the left. Negative 1 from the left, this is approaching 2. Negative 1 from the right, we're approaching 2. So the limit at negative 1 is 2. The left and the right equal each other, so there's a limit at negative 1. But what is f of negative 1? It's 1, not 2. So when this one and this one are different, what does that tell you? There's a discontinuity there. It happens to be removable, but there's a discontinuity there when those are different. Limit as x approaches negative 4, negative 4. Well, the left limit is 3. The right limit is up there at 4. So this does not exist. The limit as x approaches 4, just in general, well, the left one is negative 3. The right one is negative 2. So this one does not exist either. There's jump discontinuities there. How about 1 from the left? 1 from the left is 3. 1 from the right is also 3. So the limit is 3. And f of 1 is 3. These two things tell me that that function is continuous there. The limit and the function values are equal to each other. Limit as x approaches negative 5, another jump discontinuity. The limit at negative 5 does not exist. Another jump discontinuity over here does not exist. Questions on those? All right, these are right out of the book. Thought we'd practice a few. Show you how to do your calculator. Grab your calculators. If you don't have one, you got to get one. You got to bring it to school eventually. let's look at the first equation. We have number 6. We got 2x. Go to y equals 2x minus 1. We're going to divide that by absolute values in math and num. So if we go to math and over to num, absolute value is the first one. So absolute value of x, and then minus 3. Enter. Use the graphs and tables to find the limit as x approaches infinity, limit as x approaches negative infinity, and identify all horizontal asymptotes. That's the same question. It's the same question. Graph. And if you go zoom 6, it gives you all the negative 10 to 10s. Now, it would appear that this graph indeed is leveling out on both sides, but it's kind of hard to tell where. Is it leveling off at 2, 1, 0? Where is it leveling off? If you go to table set, it's the second function of window. Second table set up at the top. You can tell your calculator to start at 1,000 and go by ones, so you don't have to arrow down. You can tell it to where to start. So now if we go in, I'm going to press enter, I already did. Second table, what does it look like it's leveling off to? 2. It's leveling off to 2 on the right side. So letter A, find the limit as x approaches infinity, 2. Now let's go to table set and start at negative 1,000. And if we go to table, we see that it's leveling off to negative 2 on the other side. Negative 2. So letter C says, what are the horizontal asymptotes? Well, that's what we're finding. Where's it leveling off to? So there's a horizontal asymptote at y equals plus or minus 2. There's one at 2. There's one at negative 2. If this absolute value wasn't there, if it's 2x minus 1 over x minus 3, then it would level off to 2 on both the right and the left sides. But when you cause this to be positive for the positive and the negative, that's where you get one's the positive and one's the negative. That's how the absolute value kind of affects the problem. Any questions? Y equals, clear that off, sine of 2x divided by x. If we go zoom 6, make sure you're in radians, by the way. If you're in degrees, this will look like pretty much a horizontal line. So you got to be in radians. And there's that familiar squid or octopus figure. I'm going to go to window, make it look a little better. Negative 2 to 2. What's it leveling off to on the right side? 0, right? And what I mean by leveling, this one doesn't necessarily level off, but it's getting closer and closer and closer to 0. The magnitude's getting smaller and smaller. So A, 0. To the left, 0. Letter C, what are the horizontal asymptotes? Y equals 0. This one happens to be crossing that horizontal asymptote an infinite amount of times, but it is approaching that line. That's what an asymptote is. It approaches it. The definition of an asymptote never says it cannot cross. You don't ever cross vertical asymptotes, but you can cross horizontal, well, an infinite amount of times. Find the limit and confirm your answer using the sandwich theorem. What's the highest value you can have for cosine? It's the biggest value. 1, right? The biggest you can have is 1. So we have 1 minus, well, if we would say cosine is 0 over x squared. So this can be 1 minus 1 over x squared. So here's one of its extreme values, 0. So that function can be 0. When cosine is at its highest value, this one's at its lowest. At pi, cosine is negative 1. So 1 minus negative 1 over x squared. So at its highest value, this function, I mean, is at 2 over x squared. Yeah, go ahead.
So is the sandwich theorem just the highest point of the function could be the lowest?
Yep. Yep. Well, now I can put this in between 0 and 2 over x squared. So we have the limit as x approaches negative infinity of 0 is less than or equal to the limit as x approaches negative infinity of 1 minus cosine of x over x squared is less than or equal to limit as x approaches negative infinity of 2 over x squared. So it has to be in between those two things because cosine has a smallest and a highest value. That's why the sandwich theorem, or they call it the squeeze theorem, usually involves a trig function. Everybody know what the limit as x approaches negative infinity of 0 is? It's not a trick question. Y equals 0 is a horizontal line. So the limit is 0. So this piece goes to 0. Less than or equal to the limit. X approaches negative infinity of 1 minus cosine of x over x squared. Everybody know the limit? What happens to 2 over x squared as the denominator gets really big? It's going to 0, right? So didn't we just sandwich this function between two zeros? The limit has to be 0. Equals 0. Has to be. It's called the sandwich or the squeeze theorem. If you squeeze it between, well, not between two numbers, between the same number, you know what the answer is. So it all comes from the fact that cosine and sine have a highest value and a lowest value. So if you just follow this recipe, what I did, these are pretty simple, pretty straightforward. But you can still ask me how to do them. I get the more questions on this than any other problem you'll do, at least in this section. So if you got a question on it, ask. All right, back to graphs and tables. They kind of bounce around a little bit. Greatest integer is math num, I think it's number 5. Greatest integer of x divided by, oh, I don't want to do that, divided by x. Oh, what did I do? Math num 5 x divided by x. 0 from the left. So let's graph this. I'm going to do zoom 6. Oh, I don't like that view. Let's do window. How about just negative 1 to 1? What do you think it's doing? Where's it going? Infinity, right? It's headed off to infinity. Yep. So find the limit. Oh, limit is infinity. There we go. 2 from the left on x divided by x minus 2. Zoom 6. So x minus 2, there's a vertical asymptote at x equals 2. And they want to know, well, what's happening as we approach 2 from the left side? This is headed down to negative infinity. I didn't really need charts to do either one of these. I did it right off the graph. So if the graph isn't good enough, like leveling off, sometimes it's hard to tell where it's leveling off. If the graph isn't good enough, go to the chart. Go ahead.
Would we put infinity and negative infinity, or would we say it doesn't exist?
One-sided limits, I can't think of a time where a one-sided limit wouldn't exist. You're thinking of if it said limit as x approaches just 2. That does not exist. The one-sided limit is negative infinity or infinity. Good question.
Yeah.
All right, so limit as x approaches infinity and negative infinity of this function. When you have something like this, I would just take it one piece at a time. What happens when x goes to infinity for that piece? 0. So 0. Limit as x approaches anything of 1 is just 1. What about ending behavior for this right here? 5. When you're going to 3 billion, you think minus 1 really matters? 3 billion minus 1? No, doesn't matter. So for large values of x, this doesn't matter. For small values of x, it matters a lot. If you're plugging in a value of 1, that minus 1 is a big deal. When you're plugging in 55 billion, doesn't matter. So then those cancel out, you're just left with 5. 1 times 5 is 5. Yeah.
Do we include the 1 because it's not on the same part of the x? So like we didn't include the negative 1 on the right, but we included the 1 on the left.
We are really graphing. Great question. We're graphing. If you isolated this, really we're looking at the line y equals 1. What's the limit of that as x approaches infinity? 1. That's it. It's not any more than that. It's just always 1. So what is it approaching? Well, 1. It's always 1. Not even approaching it. It is 1. Find the vertical asymptotes of the graph of f of x. Describe the behavior of f of x to the left and the right of each vertical asymptote. Well, I don't need a graph to know what it is. As a matter of fact, I would just do this in my head, and you can too. But there's a vertical asymptote at negative 2. That's what makes the denominator 0. So let's graph it and see what's happening to the left and the right of that asymptote. X squared minus 1 divided by 2x plus 4. Graph. So to answer this question, we use limits. So A, find the vertical asymptote. I already knew that. X equals negative 2. And part B, we say that the limit as x approaches negative 2 from the left of f of x is equal to negative infinity. So on the left side, negative infinity, and on the right side, positive infinity. Limit x approaches negative 2 from the right is going up to positive infinity. Questions on how to answer those? All right, that's it for today.